I hope everyone's doing well. I am Mr. Ish. Thank you for joining me for this limit, which we are examining. Limit as x approaches infinity, I have x cubed divided by square root 1 plus x to the 6. For familiarity reasons, you can even write this as x to the power 6 plus 1. Some would prefer to look at it that way. Some would prefer to look at it this way. Either way, it's the same. Order does not matter when you're adding. Anyhow, this right here is our question. And how can we solve it? You will use algebra over here and it'll simplify everything greatly for you. I'm representing it as this for the student that might want to see it in this way. If you put infinity in places of x, you know you have an indeterminate limit form, infinity or infinity, and you can do the Hopital's route, you can, but you might end up in a mess doing it. It's better if you just use algebra and simplify or rewrite or re-express everything that you see, and that's the route I'm using over here. I am looking here at this x cube, which is really an x to the 6 in a square root divided by square root of x to the 6 plus 1, and you know this right here is algebraically equal to that. I've just used laws of exponents, which I will utilize once more to write everything in this way. Now look, limit as x approaches infinity, I have this, a large radical, x to the 6 divided by x to the 6 plus 1. This right here is legitimate. Root a divided by root b is equal to a large root with a over b. A very legitimate property. I'm going to use now a limit property. You see the square root? I'm going to bring it and encompass my limit with it, and you can, and there's nothing wrong with you doing that. Square root limit as x approaches infinity, I have this rational function which you have to evaluate. You can evaluate this and just determine the limiting value of this function, which would be the same thing you would do when you're trying to determine a horizontal asymptote. When you look over here, you can divide the numerator and the denominator with the highest order variable exponent. I would have x to the 6 divided by x to the 6 in the numerator. In the denominator, I have x to the 6 plus 1 divided by x to the 6. When you simplify, you have 1 divided by 1 plus 1 over x to the 6. And obviously the limit applies to this, and this you know is all in a square root anyhow. When you look at that, limit as x approaches infinity, this zeroes out. What you are really looking at now after the limit has been applied is this square root of 1, which is just equal to 1, and that right here must be your answer for this limit, and it would be right. So keep in mind, we've used multiple properties over here, but we've entirely dependent on algebra over here to simplify our original expression to avoid dealing with indeterminate limit forms. And our end result here, 1, implies that a horizontal asymptote y equals 1 is involved here. As x approaches infinity, your function approaches a horizontal asymptote y equals 1, and that brings us here to the end. Thank you.